16C, writing polynomials. Okay, let's hit the highlights. Need to know, reminder, the degree identifies the numbers of zeros. We're not going to say x-intercepts because remember they could be imaginary. So for example, if I have something like this, f of x equals x to the third plus 2x squared minus x plus 7. What is the degree? 3. So how many zeros will you have? 3. That's what fundamental theorem of algebra says. So if the degree is 3, then the number of zeros is 3. Okay, the zeros or roots are used in order to set up a polynomial in factored form, which we've been factoring since forever. That's a D. There we go. For example, if my given zeros are, let's make some up. How about 3? And also I'll do a comma. -5. If I'm given those zeros, and if I go backwards and put it in factored form, it would look like what? What parentheses does 3 come from? Yeah, x minus 3, right? So you flip the sign. What about -5 comes from? Yeah, x plus 5. Because you'd be setting those equal to 0 if you're trying to find the zeros. Okay. Multiplicity, remember, is the number of times a factor occurs in a polynomial. It's the exponent on the factor. Okay, let's have a chat about multiplicity a little bit more. This is a review. If it's an even multiplicity, the factor occurs an even typo number of times. For example, let's make one up. If I have this, x minus 2, that's a bad example because it's the same number. Hold on, x minus 1 squared. This guy right here is the multiplicity, remember? Do you remember what happens when it's an even multiplicity? Is it bounce or cross? Bounce, yeah. And that's important because we're going to be able to look at graphs and like write a possible polynomial. So if it bounces, so remember that's like if my 0 is here at 1, then we would say it's got to bounce like that. Just for example, okay? But my factor was x minus 1, so that means the 0 that comes from that, right, is x equals 1. Okay, if it's odd multiplicity, I think we went a little too fast when we made this packet. The factor occurs an odd number of times. Sorry, it didn't even say even, it says either, which isn't a word. Okay, an odd number of times. For example, let's make one up. If I have, we're actually going to do 2. If I have like x minus 1 and also, what do we think? X plus 3 to the third. So both of these actually have an odd multiplicity. Do you remember what happens then? Cross. So if my 2 x-intercepts are at 1 and -3, and they're both crossing, then it looks like, hold on, I think I did this wrong. Does this work? How does this work? Hold on. So where they're both crossing at those zeros, because they both have an odd multiplicity. Sorry, that took me a second. It's odd. No, it's even, positive. So they both be up, up. Okay. If a plus bi is a root, since we always have plus or minus, a minus bi is also a root. And then last thing that we're doing today is a point. So keep in mind that you can have a polynomial that's been vertically stretched by any non-zero constant and retain the same zeros, meaning the factors are all the same, but you might be like a number out in front. So you'll need to have a to solve for that. So for example, if I have something like this, f of x is equal to a, and this is what we're doing today, x minus 1, I don't know, x plus 2. What you will do today is plug in a point and solve for a. Great. So a quick review for you. Your factors that you see are x minus 3, x plus 2. And then I'll switch colors what? Then we get some information from that. So we'll do the x, right? The multiplicity on that, you don't see an exponent, so it's a 1. That means that since it has an odd exponent, the behavior will bounce across. Cross, this is odd. And the 0 that comes from that, if I set that equal to 0, is x equals 0. You look at your next factor. X minus 3 has a multiplicity of 3 as the exponent. The behavior, since it's odd, it will cross. This is helpful if you're like planning to retake. And the 0 that I get from that, x minus 3 equals 0. I set it equal to 0, and it's 3. Okay, can you do the last column? Multiplicity is 2. So it's going to bounce, hit the axis, and go back up. And the 0 is x equals, sorry, that's kind of hard to see. I'll put it below. X equals negative 2. All right, so it says that my degree is 2, and meaning it's quadratic. The zeros that I have are negative 5 and 3, and it has no multiplicity, meaning that like none of them are anything other than 1, okay? There are no conjugates, none, because do you have any i's? No. The only time you would have to deal with conjugates or complex conjugates is when you have an I. And then this guy over here is going to give me a point in a second. So let's go ahead and write it in our form here. So y is equal to, what you're going to have to do in a second is solve for a. That's the leading coefficient, the thing that causes a stretch. But then you have 2 zeros. So you have to go backwards. If my 0 is negative 5, what parentheses does it come from? Positive 5. If my 0 is 3, it comes from minus 3. Okay, and then here's the part that's a little bit different today. The point that you are going to use is, it says p of 0 is negative 30. That means when I plug in x as 0, I get out a negative 30 for y. So this is an x, y coordinate. You're going to take those numbers and plug them in. So in place of y, you put negative 30. And then we'll keep the rest of this the same, is equal to a. Well, kind of. We're going to plug in for x as well. But let me write this in black first, and I'll go back. Okay, and then the x is 0. And now your job is to simplify it. So we figure out what each of these parentheses are. 0 plus 5 is 5. So I'm going to just write 5 in that first parentheses. 0 minus 3 is negative 3. And then we multiply those together to get this baby equation. That would be 5 times negative 3 is negative 15a. And then if I divide by negative 15, I get a to be negative 30 divided by negative 15 is positive 2. Okay, this guy is part of your final answer, but it's not the whole thing, because you want to now write it in the full function. So write the polynomial function is what we're doing. I'm going to put it in f of x form just because I want you to see it like that. The a value is 2. That's also the leading coefficient, right? So we know it's a positive function. And then your 2 factors go here, x plus 5, x minus 3. Ta-da! That's what we're doing today, okay? So you will have to write it in factored form, plug in a point to solve for a, and then put it back together for me. Okay, so try that. Which ones can you fill in for sure? If you're confused about 1/3, you could leave that for now and just do the other 2. What one, or what factor does that come from? Negative 5 comes from plus 5, right? What about negative 1? Plus 1. Okay, and this one is weird. So I know a couple of us use slide and divide to factor, and for those of you who do that, this will make a little bit more sense, but If I was doing 1/3, it would look like this, right? But do you typically see factors like that? No, not with a fraction. And so what you have to do to make this work is you have to slide that up in front like this and put it up there in front of the x. And then you know that your factor that 1/3 comes from is 3x minus 1. And you can check that, right? If I take 3x minus 1, I set equal to 0, I would add 1 and divide by 3. Okay? So if it helps you to write it out like this first, and then imagine you're sliding this number here, the one on the bottom, that 3, slides up in front. Okay. At this point, I'm going to mostly stop talking in a second. Conjugates. Are there any i's? In this, nope, no zeros with i's, so you would say none. And then the point that we are plugging in is the point x equals 0, y equals 5. So this is your x, y. And you're going to put 5 in for y and 0 in for x. 5 goes here, is equal to a, and then 3 times 0 minus 1, 0 plus 5, 0 plus 1. Okay, your job is to simplify each of those parentheses and then see what would it be, blank a. Can you please work the people around you? Okay, so -1 times 5 times 1 is 5 times -1, or -5. So then you have this. Make sure you don't add the 5. We're dividing by it. And so that would give me a to be -1. Okay, here's your a value, which is great and all, except that you're not done because I need you to write the actual function. And so you can like circle it or something. Obviously it's important, but then you're just taking this and you are giving the final answer here. So f of x is equal to, you could do -1 or you can just do negative. And then the 3 parentheses that we already chatted about, which would be 3x minus 1, x plus 5, x plus 1. Ta-da! -1 comes from what parentheses? X plus 1. And then 2 comes from -2, but then it has a multiplicity of 2. And that checks out because you add up the exponents here. 1 plus 2 is 3. There's my degree of 3, okay? Conjugates. Do you have any i's this time? I don't know. It's coming for you on the next page, I promise. Okay. So that's just there to help you think through it. And then the point that you are plugging in here shortly is what? 0, 12. Okay, so I will set that up for you, and then I'm going to let you do the rest. So 12 is y. You just have to be careful because you have an exponent. So +1, -2, that's squared. You do have to simplify inside the parentheses first, and then square it, okay? Because PEMDAS. Okay, can you try that? Go. Do you know what -2 squared is? It's -2 times -2, which is +4. And then that would give me 4a. So a is 3. Okay, and then you just have to take that guy and put it back. So final answer comes from putting that in for a, and I will go ahead and put it in f of x or function notation as well. So 3 times your factors, x plus 1 and x minus 2 squared, and then you can double check your work and make sure this all checks out. Has a degree of 3? Yes, because this one has a 1. 1 plus 2 is 3. Multiplicity of 2 on the exponent, or the one that has a 2, and then -1 is my other 0. There's no i's, and then you plugged in and solved. Yep. Okay, you ready to do some i's? Yes. Last week we said Okay, you look at the graph, you're going to see certain things like graphed for you on Desmos, but then some of them you don't see because they're imaginary. So this is that moment, right? Has a degree of 3, but it's only telling you 2 of the zeros. It's telling you that you have 5 and negative 2i. The complex conjugate theorem says that if I have negative 2i, I also have to have positive 2i. So this one. So conjugates, yes, because you have I. That's when you use conjugates. Okay, so let's go ahead and put it in factored form. Y is equal to A, because we don't know what it is yet. You have 3 zeros, actually, right? You can't put the i's in the same one. So it'd be x minus 5. Okay, negative 2i comes from x plus 2i. And then x minus 2i. Okay. We love it. What point are we plugging in? This is a big one. 0, 160. So there's your x and your y. It's going to actually work out really nicely, I promise. So 160 goes over here for y. And then let me rewrite the right side, and then I'll plug in 0 in a second. Oh, lots of i's. Okay, let's see what you remember about multiplying out i's. Here we go. We're going to simplify these little baby parentheses. So we've got 0 minus 5 is negative 5. Okay, so that's your nice one. I'm just going to do it like this. Okay, what about 0 plus 2i? It's just 2i, because you're adding. It doesn't do anything. Okay, and then 0 minus 2i is just negative 2i. Okay, you can't leave it like that, because remember what happens when you have I times I, it actually is going to simplify out nicely, so you need to multiply these together. 2i times negative 2i, negative 4. Do you remember what I times I is? I squared. Shoot. And then here's another good question. Do you remember what I squared is? Because that's important. Negative 1. Okay, so you're going to make a note to yourself. I squared is equal to negative 1. This is an important thing that you need to remember. Okay, so that's what's happening here. Okay? So negative 4 times negative 1. Positive 4. I can't remember. Did we do that this semester or was that last semester? I think last semester, yeah. Negative 5, sorry. I'm writing it a million times because I want you to like have notes that are helpful. Negative 5 times 4, so finally you get negative 20a. And then 160 divided by negative 20 is, you can use quick math, 16 divided by 2 is 8. There's just zeros there, so negative 8. There it is. Okay, so now you just need to put it in final factored form. So we're going to use f of x. F of x is equal to negative 8. And then all this rest of the stuff you already know, right? X minus 5, x plus 2i, x minus 2i. Easy. I know it's weird and it's been a while since you dealt with i's like that, but it's good for you. We're going to skip F for now, and I maybe will come back and talk about it tomorrow, but what I'd like you to do with people around you is look at this very last one. It's a graph, actually, and it asks you to, okay, look at the graph. Based on the zeros that you see, can you write it in factored form? So I think that's what, G? So here it is, yeah. Sorry, are we not done? You have a question? So you need to look at your zeros, and you can identify them, right, just by looking at the graph. You don't have to deal with imaginary ones. You just have to look and see what you're given. Because it says write a possible one. Doesn't mean that it has to be perfect, but you can get pretty dang close. So x is equal to I think you've done this maybe on Desmos before, or Delta Math. -5, right? -2, 0, 3, and 6. So given those zeros, can you put it in factored form? Try it. There would be 4 in parentheses, and there's one that's not. Okay, do you remember when you have a 0 of 0, where does it come from? The x in front, like that. Okay, and then you can check this, like check your degree. My degree is 1, 2, 3, 4, 5, because they all have a multiplicity of 1. So degree is 5. Which means it's odd. And if you look at your end behavior, it's down, up. Which means it needs to be positive, and my leading coefficient is positive, so I should be good. Okay, so just checking those things. We've done this kind of before.